Chapter 6, Relationships within Triangles. Now, Chapter 6 does start us on geometry. 6.1 is proving geometric relationships. If we're going to start geometry and we're going to be proving geometric relationships, then the first thing we're going to need is we're going to need a whole bunch of properties. So, starting out, we have the addition property of equality. An example here, let's say we had x minus 3 equals 7. If we were going to solve this, then we would add 3, and we would add 3. That would get us x equals 10, but really right here is the addition property of equality. We added 3 to both sides of the equation. Next, subtraction property of equality. So let's say we had x plus 5 equals 9. So if we were going to solve this, we would subtract 5 and subtract 5, which would get us x equals 4. But right here is the subtraction property of equality because we subtracted 5 from both sides. Multiplication property of equality. Let's say we had 1/3 x equals 5. If I was going to try to get the 1/3 to the other side, I could multiply both sides of the equation by 3 so that the 3 and the 1/3 would cancel. And right here is the multiplication property of equality because we're multiplying by the same thing on both sides. Division property of equality. So let's say we changed it to 3x equals 21. Here we could divide both sides of the equation by 3, and then right there is the division property of equality. The distributive property, let's say we had 3 times x plus 2. We would take that, we could distribute the 3, which would give us 3x plus 6, and that's the distributive property. Now, this one has an or, because the other version of the distributive property would be 3x plus 6, and then we could turn that into 3 times x plus 2. So notice here we went the other direction. So instead of distributing the 3 in, we factored the 3 back out. Okay, so either one of these, whether you see it being factored out or whether you see it being distributed in, both count as the distributive property. Okay, combine like terms. Let's say we had 7x plus 2 minus 9x. If we were going to combine like terms, we would take the 7x, we would take the negative 9x, that would give us negative 2x, and then plus 2, and that's an example of combine like terms. Substitution property. Let's say we had 3x plus 1, and we know that x equals 2. Substitution property says that we can take 3, and instead of multiplying by x, we're going to substitute the 2 plus 1, which is going to get us 6 plus 1, which ultimately is 7. But right here is the substitution property. If I know something equals something else, I can substitute it in its place. Okay, reflexive property. If x equals 1, then 1, oh, sorry, that's the wrong property. So the reflexive property is just simply 1 equals 1. Or x equals x. So I usually think of it as reflexive, being you're reflecting yourself in a mirror. In geometry, you're going to use this for like different segments. You're going to say, okay, if the length of segment AB is 5, then the length of segment AB is 5, or AB equals AB. Okay, symmetric property, this is the one I almost confused it with, is if x equals 1, then 1 equals x. Okay, so if you can say it going this direction, you can also say it going this direction. It kind of flips. And then last but not least, we have the transitive property. So if A is equal to B and B is equal to C, then we can say A is equal to C. Okay, I usually call this kind of like you cut out the middleman. So A is B, B is C. We can kind of like get rid of the B's and just say, okay, well, if they're both equal to the same thing, then I know that they're equal to each other. That's the transitive property. What property is used? Number 1, if AR and then this sign right here, do we remember this sign right here? That sign, if we forgot, is congruent. Okay, and congruent kind of means equal. They're the same shape, same size, same everything. That's congruent, so equal. So if AR is congruent to TY, then TY is congruent to AR. That is your symmetric property. Just kind of like flips it around. Okay, number 2, 3 times x plus 5 equals 9. So then we can say 3x plus 15 equals 9. That is your distributive. Okay, so they took the 3 and they distributed in to get the second line. Number 3, 1/4 x equals 7, so x equals 28. I'm going to choose that this is the multiplication property of equality. Or if you had said division, I would also take that. So if I were to solve this, I would multiply both sides by 4. But another option, if you really wanted to, would be to divide by 1/4. So either one works. Number 4. Okay, now right here, we already went over that this is congruent. So this is read as the measure of angle R. Okay, and this is your angle sign. That means measure. So the measure of angle R is congruent to the measure of angle P. Then the measure of angle P is congruent to the measure of angle X. So then the measure of angle R is congruent to the measure of angle X. This one is your transitive property. Okay, so really M is equal to P, P is equal to X. So you really don't need the P's because they're both equal to P. So we can say then they're equal to each other. Number 5, ST is congruent to QR, so QR is congruent to ST. This one is your symmetric again. It has been flipped. Number 6, AB minus BC equals 12. So AB equals 12 plus BC. This is your addition property of equality. Because here you're just going to add the BC. So you would add the BC, which would get you 12 plus BC. And then it would get rid of it from that side of your equation. Number 7, AB equals AB, so AB equals AB. This is your reflexive. Again, I think of reflexive as like reflecting in a mirror. You're looking at yourself. So AB reflected in a mirror is the same thing as AB. Number 8, if the measure of angle A equals 15 degrees and the measure of angle C equals the measure of angle A plus 12, then I can say the measure of angle C equals 27. Pause your video, try this one. When you think you have it, come back. But this one is actually substitution. What's happening here is I'm saying, okay, I know the measure of angle A is 15. So I'm going to take 15 and I'm going to substitute it N for the measure of angle A. So then I'd have measure of angle C equals substitution 15 plus 12. And then in order to make the leap over to this statement, you just simplify. Okay, that's not transitive or anything like that. It's substituting in here and then just simplifying. 15 plus 12 is 27. Number 9, 30 equals x, so x equals 30. That once again is symmetric. They're just being flipped around. And then number 10, if A equals B and B equals C, then A equals C. This one is transitive. Because if they're both equal to B, then we really don't need the B. We can just say A is equal to C.